Okay, so this is for us to review the centers of triangles. Remember, there are actually 3 different center points that we're going to talk about this year of how we can find a center, which can seem really strange, but there are different centers depending on what you're finding. We have one center that finds equal distance between points. We have a center that finds equal distance between sides. And then we have a center that's actually the balance point, which just kind of finds the equal distance in areas. Would be a way to think about that. So I want to do each of them, review the vocab, and this could be a kind of a checkpoint for you to see if you have all 3. So this first one here, okay, I'm going to do our very first construction that we learned. And I want to find equal distance to points. Okay, so that means if this is considered a point, let's just say there are 3 towns, and I want to find the place where we can meet up. If those are the 3 towns, what I need to do is I need to do perpendicular bisector. And I know that, okay, because if I put in a perpendicular bisector here, so arc on this side, arc on this side, I'm going to draw on this whole line between the 2 of them. Okay. Anything on this line right here for the perpendicular bisector I can see is equal distance between here and here, no matter where I am on that line. Okay. Now drawing one line isn't actually enough information. I have to perpendicularly bisect every single side because that just gives them information about those 2 points. But I actually need information about each of the sides. So let's do that one. Okay, and then the third side, so now this line gives us all the possible solutions between these 2 points. Now I need to find all the possible solutions that are equal between the last side. Did not connect that enough up here. Okay, last perpendicular bisector here for the last side. Okay. And lucky for me, I do see that all 3 of them match up right here. Okay. So again, I cut one line in half, cut the other line in half, cut the third line in half. That should show me that I have all the solutions possible when they all meet. There's actually only one answer for the 3 lines where this point is going to be equal distance to every single point. Now it looks like it when I kind of eyeball it, but let's actually confirm and check for accuracy. So I'm going to extend this. This is how far it is to this town. Okay, let's see. Nice. It looks like the same distance to the second town, and sure enough, that third town is actually just as far away. Okay. To give our vocab for this is called circumcenter. Okay, and I'm going to use perpendicular bisectors to find equal distance to the points. So to help, I actually drew the exact same triangle, but this time what we're going to do is find the in-center. Okay, and if you don't remember in-center, then that's going to be equal distance to the sides. And we're going to do angle bisectors for this because the circle is going to end up being inside if it's equal to the sides. So let's look at this construction together here. So if I want to find a place where a line can be drawn that's equal to the sides, I am going to draw an arc, find a center point, and then draw the, sorry, I drew the line slightly off. Okay. Let's try the next one. So again, if I want to find equal between the 2 sides, I'm going to have this angle bisector here, where I can then cut the angle in half. When I cut an angle in half, the line I draw will be equal distance to the 2 sides. And the very last one, with this motion that I'm doing to make those second tick or arc marks, show us that where the middle is, so that I can find distance. Oop, I am going to be slightly off on this construction. Okay, probably resulting in that fact. Hopefully yours is going to be slightly better. I'll have to give that center point there. Okay. All right, let's see how close I am, because I look like I'm a little off. So, to be equal to this side, I have to be this wide. Now let's see if I draw this circle inside for the in-center, if I can hit all these sides. So, first one, second one, third one. Okay, I'm slightly off, but it's not horrible. Okay, we'll get full points for that on the quiz. See how this center here is very, very different than our first center. Okay, our first center is even outside the triangle, and that's the only spot that would hit all on the outside. This center, this is the only spot that we could use our compass for would hit all on the inside. Okay, our last construction is going to be new, but I'm going to preview for that for you. Okay, this one is going to be called a centroid. It is going to be the third and final construction that we do to find centers. There's actually a center called an orthocenter, but we won't be doing that in this class. Centroids find a balance point. And what they do is they split up the triangle into equal areas. Okay, so let's think about how we do that. Now we know the midpoint's important to find middle, so I'm actually going to do that first here. So, for arc each side. Instead of drawing the whole line in for the perpendicular bisector, because I'm not trying to find where all the points are, I just am trying to find the middle. I will put this middle in here. Okay. Now, the interesting part is if we find the middle of the bottom and then we draw back to the vertex on the opposite side, that right there, these two areas that I've divided up are actually exactly the same. So if I held up this triangle and I held it on that line, it'd actually be equal areas and it would balance. However, we have to find out exactly what point on this line we could do that so that all three sides are going to be able to balance. So now we'll do the same construction just like we have on the other ones for the next side as well. Okay, so again, I don't have to draw on the whole line, just the dot. That right there is equal distance to the two sides, put those tick marks. And then what I do is I draw back to the angle. Okay. Alright, now it should already looks like it's going to be that point, but let's just confirm. First side. Oh! Clearly I didn't reach over halfway, so I can't find the middle point. I have to mark it again, sorry. Okay, so there's that. There's that. Okay, so let me clean that up. Sorry, there's the extra lines on there. But again, it doesn't matter how wide you've opened it as long as you have a cross point so you can find the middle. Draw across to the equal vertex from the midpoint. This line right here is actually called a median. Okay, luckily accurate construction, that right there is the balance point where if I cut this out, it would all be balanced. Okay, the interesting part is we can't draw a circle. You'd see if I tried to draw a circle that was equal distance to all the sides. You see how it's not going to work? How far off from this side it'd be if it was on the trying to find the in-center. So I know that's not really the in-center. I know if I try to line this up to try to see equal distance between all the points, wow, I'm way off. I'm too short on this, I'm too long on this one. So both of these don't work. The only thing left that we're going to be talking about is this is the centroid. Okay, there's no way you can check with circles because it's balanced, so the only thing you could actually do is cut it out and try to balance it, which actually would work. So again, these are our three centers. All the same triangles have three different centers. Okay, these different centers represent different center points. So this first one, we use perpendicular bisectors to find the center between 3 points. It's called the circumcenter. The second one, we're trying to find equal distance, a center that's equal distance to all the sides. We use angle bisectors, and it's called the in-center. And the last one, we use medians, I should write that on there, which connect the midpoint to the vertex across to find a balance point, which splits up the triangle into equal areas, so that this point right here is actually a place where you could balance a triangle. Ask more questions in class. We have a whole nother week where we're doing nothing but these three constructions. You can draw any triangle and practice all three of them for yourself at any point using that compass. Good luck.